Good morning, children. So today we are going to start second derivative test for finding extremum values. So let us see the steps involved in this test. So what we'll do is a function will be given to us. Okay. So firstly we'll find the derivative of that function. Clear? Thereafter, whatever value comes in that derivative, okay, you have to put that equal to 0. Okay. You have to put that equal to 0. Okay, and you have to solve that. After solving, you'll get some values of x. Okay, so let's say I get x equal to c. Done. Now in the third step, what we'll do is whatever you had got in the first step, okay, after differentiation, you got to differentiate that again. Okay, that means you are finding the second derivative. Okay, so whatever you had got in the first step, differentiate again, so you'll get the second derivative. And what we will do next is, in this second derivative, in place of x, we will replace c. Okay, we'll put in place of x, we'll put c. Okay, and we'll find that value of that second derivative at c. So what we'll get to see is, if you see that value of derivative at c is coming less than 0, okay, then this would imply that x equal to c is the point of maximum. Okay, and if you see that derivative at x equal to c is coming greater than 0, that means x equal to c is the point of minimum. Okay, and next, if you find that derivative is coming 0 when you are replacing x by c, then in that case we have to use the first derivative test. Okay, this first derivative test was explained in the previous lecture. Next is, if you find that second derivative is coming equal to 0, okay, and then what you do is again differentiate this. Okay, that means you have to find the third derivative. Okay, and for the third derivative you find the value of that third derivative for x equal to c, and in that case, if you get that third derivative at c not equal to 0, okay, then we would say that x equal to c is the point of inflation. Okay, so now let us see the questions. Okay, so exercise 10a. Here I have taken question 1. So in question 1, short answer type question, find the absolute maximum and minimum values of the following functions in the indicated intervals without using derivative. So here we don't have to use that second derivative test. Okay, so let's see how we can find the its maximum and minimum value. So first is fx equal to 2x plus 7. So we have got function 2x plus 7, and this function is defined for this closed interval 0, 4. Okay, so here clearly this 2x plus 7, okay, for this interval, okay, no matter what value you take, okay, this function will increase as the value of x increases. Clear? So clearly for x equal to 0, this will give you minimum. Okay, and for x equal to 4, this function will give you maximum. So absolute minimum value is of this function is f of 0, that is 7. So here point of minimum is 0 and the minimum value is 7, and the point of maximum is 4, and maximum value of this function is 15. Okay, now let us see the next question. Here next question is fx equal to cos x. So function is given to us and this function is in R. That means x can be taken anything from R. Okay, your function is defined on R. So you know that value of cos, okay, no matter what you take here in place of x, okay, this value will lie between -1 and 1. Okay, so we know that cos x is greater than equal to -1 and less than equal to 1 for every real number. Okay, so here clearly the maximum value of this this function cos x will be 1 and the minimum value will be -1. Okay, now let us move on to next question from B. Okay, so exercise 10B, question number 1. So let us see the question. So here, show that f of x equal to x cube minus 6x squared plus 9x minus 8 has a maximum value at x equal to 1 and a minimum value at x equal to 3. Okay, so function is given to us. So in this case, we have to show that for x equal to 1, okay, this function will give you maximum. Okay, and for x equal to 3, this function will be minimum. So what we'll do is we will use that second derivative test over here. Okay, so so we are given this. So you know that for the second derivative test, first step is whatever function is given to you, you are supposed to differentiate it. Okay, so after differentiating, you will get 3x squared minus 12x plus 9. Okay, now first step is differentiation. Second step is, you know that for maximum or minimum value, that first derivative has to be equal to 0. So that's why we will put this first derivative equal to 0. Okay, so f dash x equal to 0, that means we have to put this equal to 0. So 3x squared minus 12x plus 9 equal to 0. Now you can see this is a quadratic equation. Okay, so solve this equation and at the end you will get two values of x equal to 1 and 3. Now we don't know that whether 1 is maximum, point of maximum, or 3 is point of maximum. Okay, so right now we cannot say which one of these is maximum and which one is for minimum. Okay, so what we'll do is, next step is we have to find the second derivative. For second derivative, what we will do is, whatever you have got here after the first differentiation, okay, differentiate it again. Okay, so after differentiating this, you will get 6x minus 12. Okay, so you got second derivative. Now next is for this second derivative. Okay, value of this second derivative has to be found for 1 and 3. Okay, so firstly we'll find for x equal to 1. Okay, so second derivative for x equal to 1 will be, okay, wherever you see x, you have to replace by 1. So you get minus 6, which is less than 0. Okay, so therefore x equal to 1 is the point of maximum, because second derivative at x equal to 1 is coming less than 0. So x equal to 1 is the point of maximum. Okay, and next we'll check the second derivative for x equal to 3. So you just replace in that second derivative x by 3. So you get 6 into 3 minus 12, that means 18 minus 12, that is 6, which is greater than 0. Therefore x equal to 3 is the point of minimum. Okay, and in this question we were also supposed to find the maximum value. So we know that x at x equal to 1 function is maximum, so f of 1. Okay, so in this function, in the given function, you replace x by 1, so you will get the maximum value of that function. So maximum value of this function is minus 4. Okay, and for minimum value, you know that the function gives you minimum value when x is equal to 3. So in this function fx, you replace x by 3 and you will get the minimum value of that function. Okay, okay, so our next question is question number 9. Okay, so let us see what does this question says. So question number 9, show that x equal to 0 and x equal to 1 are the points of inflection of the curve y equal to 2x to the power 4 minus 4 into x to the power 3 plus 3. So this function is given to us, okay, this curve, and they are saying that x equal to 0 and x equal to 1. Okay, these 2 points are points of inflection. Okay, so let us see. So firstly what we have to do is we have to differentiate that function. Okay, first step. So after differentiation, we got 8x cube minus 12x square. Okay, then second step is to put this first derivative equal to 0. Okay, because we know that for the point of maximum and minimum, the first derivative is always equal to 0. So first derivative equal to 0, that means 8x cube minus 12x square equal to 0. Now you simplify this, so you will get x square equal to 0 and 2x minus 3 equal to 0. So x square 0 means x equal to 0, and 2x minus 3 is equal to 0 means x equal to 3 by 2. Okay, so you got two values over here. Now next is you have to find the second derivative. Okay, for second derivative, whatever you had got in this first derivative, you have to differentiate that again. Okay, so you get 24x square minus 24x. 24 is common, so it comes out. X is common, so I'm writing on this side. So 24 in bracket x minus 1 into x. Now what we'll do is, we have got two values of x equal to 0 and x equal to 3 by 2. We don't know which one is point of minimum and which one is point of maximum. That we would come to know only after putting their values for the second derivative. Okay, so we will find the second derivative for x equal to 0. So in this second derivative, wherever you see x, replaced by 0. So you get second derivative equal to 0. Okay, so this is neither less than 0 nor greater than 0. Okay, so we cannot say about the point of maximum or minimum. Okay, so what we'll do is, we will find the third derivative of that function. So we know that second derivative is this, so differentiate this again to get the third derivative. So when you differentiate this, you will get 48x minus 24. Okay, now what you do is find the third derivative for x equal to 0. So when you replace x by 0, you get minus 24. Okay, which is not equal to 0. So since this third derivative at x equal to 0 is not equal to 0, okay, so this x equal to 0 is a point of inflation. Okay, we had discussed this, okay, when we were looking at the steps of the second derivative test. Okay, and for x equal to 3 by 2, okay, we will check what is the sign of the second derivative for x equal to 3 by 2. So for the second derivative, wherever you see x, replace that by 3 by 2. So after solving, you get 18, which is greater than 0. Okay, that means x equal to 3 by 2 is the point of minimum. Okay, because here you got second derivative for x equal to 3 by 2 greater than 0. That's why x equal to 3 by 2 is point of minimum. Okay, so but in this question, they had given one extra point also, x equal to 1. Okay, and we had to show that for x equal to 1, this function x equal to 1 is the point of inflation for this function. Okay, so what we'll do is, for this x equal to 1, firstly we will check what is the value of the second derivative. Okay, so second derivative for x equal to 1 is coming 0. Then we'll check the value of third derivative for x equal to 1. So third derivative is coming 24, which is not equal to 0. So x equal to 1 is also the point, is also a point of inflation. Okay, so this question is done. Now next question is question number 12. Okay, this question had come in ISC. So before we see the solution, let us see the question. Okay, so question number 12.1. Here the question says, a window is in the form of a rectangle, okay, together with a semicircle. So a window is in the form of rectangle together with a semicircle. So you can see over here, I have drawn the window. Okay, so it is rectangular. Okay, and on top you can see semicircle is there. Okay, so the question is saying that we have got a window of this type. Okay, now a window is in the form of a rectangle together with a semicircle on the top side as diameter. Okay, if the perimeter of the window is 80 inches, determine the dimension of the rectangle so that maximum amount of light may be admitted. Okay. So here shape of the window is given to you. Okay. And next they have given you perimeter of the window. Okay. That means length of its boundary. Okay. What we have to determine? We have to determine the dimensions of the rectangle. Okay. We have to find what should be the length and breadth of the rectangle so that maximum amount of light may be admitted. So when you'll get maximum amount of light when the area of that rectangle is maximum. Yes or no? So this is the window, and they are saying what should be the length and breadth of this rectangle so that maximum amount of light can come in. Okay. So obviously when this area of this rectangle is maximum, in that case you will get maximum amount of light entering inside. Yes or no? So here we want to find maximum area. Okay, we want to know when we will get maximum area, okay, for this rectangle. Okay, so here we are talking about maximum area. So what we have to do is we have to frame an expression. Okay, we have to frame an expression of area, okay, of this window. Okay, we have to frame an expression, okay, for this window. Okay, and then we will see for what value, okay, for what length, okay, for what length that area will be maximum. Okay, so here perimeter is given 80 inches. Done. So perimeter means what? Perimeter means this length. Okay, before I read this, so here I have taken this length to be x. Okay, and here since this side is acting as diameter for this semicircle, so I have taken this radius to be r. Okay, that means this total length will be 2r. Okay, so that's why 2r over here. This is x, this is x, this is r, radius for this semicircle, and therefore this total diameter. Okay, that means length, this breadth will be 2r. Okay, so now let us see. So perimeter is given 80 inches. So that means perimeter means this 2r, okay, then this length x, okay, then this circumference, okay, half of this, okay, half of the circle. Okay, so that means here that boundary of this semicircle, okay, and this x. So 2r plus 2x, x plus x, 2x plus half 2 pi r. Okay, because total circumference, okay, is given by 2 pi r. Okay, circumference is 2 pi r. So here length from here till here will be half of 2 pi r. Okay, so perimeter is 80 inch. So that's what we have written here. Okay, 2r plus this 2x plus half 2 pi r. Now we are putting r together. So 2r plus pi r plus 2x equal to 80. Done. Now here r is common, so we got 2 plus pi into r plus 2x equal to 80. So you know that here we are looking for the length, okay, and breadth of the rectangle, okay, so that maximum amount of light can pass through this window. So maximum amount of light will pass only if the area of this window is maximum. Yes or no? So what we have to do is with the given data, okay, with the given information, we have to frame an expression for area of this window. Okay, but make sure when you frame the expression, that expression should involve only one variable. Okay, only one variable, and with respect to that we will differentiate that area, okay, that function, the area function. Okay, so here till now what we have done is we have found the value of x. Okay, we have found the value of x. Now area of this window will be what? Area of this rectangle plus area of this semicircle. Okay, so now area we will denote by capital letter A. So area will be 2r into x. This 2rx is the area of rectangle. Okay, because 2r is this length and this is x. Okay, so 2r into x will be the area of this rectangle. Now we have to add area of this semicircle. So area of this semicircle will be half pi r square. Okay, so you simplify this. Okay, so here you can see that here in this expression we have got this expression in terms of r as well as x, but I told you that you have to frame that expression of area, but make sure that expression should involve only one variable. So either you write this expression in terms of x or r. Okay, so here I'm going to write this expression in terms of r. So that means I have to replace this x. Okay, I have to replace this x by an expression which involves r. Okay, so already we know that x equal to this, okay, in terms of r. So in place of x I will write this. Okay, now simplify this. So this 2 and this 2 will get cancelled. Okay, now open the bracket, so you get 80r minus, okay, then in bracket 2 plus pi r, this r will multiply, so it will become a square plus pi r square upon 2. Okay, so here you see that we got the expression for area in terms of one variable. Okay, now what we will do is we will find the value of r. We will find the value of r for which your area is maximum. Okay, so once the value of r is found, then automatically you can find the value of x also. Okay, so that's how you can find the dimension of the rectangle, okay, for which the area, okay, will be maximum. Okay, so that maximum amount of light can enter. Okay, so now maximum amount of light will enter only if area is maximum. Okay, so what we'll do, we'll find when area is maximum. So for that we got to differentiate this function of this area. Okay, so dA upon dr. Okay, because here this area is written in r. Okay, in terms of r. Okay, so we have to differentiate this area in terms of r with respect to r. So after differentiating, okay, when you will differentiate, at the end you will get 80 minus 4r minus pi r. Okay, so this is the first derivative. Okay, and you know that any function, okay, will be when you find the derivative, second step is to put that derivative equal to 0 in order to find the maximum point and the minimum point. Okay, so what we'll do is we will put this first derivative equal to 0. So once you put equal to 0, then solve it and you get here r equal to 80 upon 4 plus pi. Okay, so here we got value of r, but right now we don't know that whether this r is point of maximum or minimum. Okay, so next step is to find the second derivative. So for second derivative you have to differentiate the first derivative again. Okay, whatever you have got, this you have to differentiate it again. So after differentiating you get minus 4 minus pi, that means minus, in bracket you can see 4 plus pi, and clearly you can see that this second derivative is free from r. Okay, it is free from r, it is actually a constant value. Okay, 4 is constant, pi is constant, and clearly it is coming negative. Okay, so second derivative is less than 0. Okay, so obviously for r equal to 80 upon 4 plus pi also, this second derivative will be less than 0. That means your area will be maximum, your area will be maximum when the value of r is 80 upon 4 plus pi. Done. So you know that when r is equal to 80 upon 4 plus pi, then area is maximum. So you know that your this is 2r. Okay, so what should be this length? So simply you have to find 2r. Okay, so multiply this numerator by 2. So length should be 160 upon 4 plus pi. Okay, and width, that means x. Okay, x should be this value you had already found here, x here. Okay, so in this expression you replace the r by 80 upon 4 plus pi. Okay, so that's how you get the width. Okay, so this is the width. Okay, and height of the window. Okay, you can find the height of the window also. So height of the window will be what? Height of the window will be x plus radius. Yes, so radius is what? R. So x plus r will be the height. So you can find the height of this window also. So height of the window is x plus r. So add it, you will get the height. So you got the dimension for the window. Okay, for which the light will maximum amount of light will enter. Okay, next question is question number 12 2. This I have left as homework for you, and the question says a figure consists of semicircle with a rectangle on its diameter. So the figure would look same as what we have drawn for question number 12.1. Given that perimeter of the figure is 20 meter, find its dimension in order that its area may be maximum. So this is same as question number 1. So you got to try this by yourself. Okay. Next question is question number 13.2. So here question number 13.2. Okay. Here it says a closed right circular cylinder, okay, has volume 539 upon 2 cubic units. Find the radius and the height of the cylinder so that the total surface area is minimum. So here we have got a cylinder, right circular cylinder, whose volume is already given to us. So volume is known to us. They are saying what should be the radius and height of that cylinder, okay, so that its surface area is minimum. So here we are talking about surface area to be minimum. Okay, so in this question you have to frame an expression. Okay, you have to frame an expression, or you say equation, for surface area. Okay, and make sure that equation or expression should involve only one variable. Okay, and with respect to that you will differentiate. Okay, then you will see, okay, for what value it is minimum. Okay, and that way you can find the radius and height. Okay, so here one thing is given to us, that cylinder, that particular cylinder should have volume this. Okay, and next what we have to find is its radius and height. Okay, and we have to find the radius and heights such that that surface area should be minimum. So we have to frame the expression for the surface area. Okay, so let us see the question. So here this is the right circular cylinder. Okay, this is the height. I have taken radius to be r. Volume is already given to us. So v equal to pi r square h is, this v is constant for us. Okay, and next what it's saying is we have to find its radius and height. Okay, so that its total surface area should be minimum. So here you should make sure that it's saying total surface area. Okay, so when it says total surface area, that means this lateral surface area, this curved surface area, okay, plus this area of the top and the bottom have to be included. So this curved surface area is given by 2 pi rh, and top and bottom are nothing but circles. Okay, so pi r square and pi r square, so 2 pi r square. Okay, so total surface area is this 2 pi rh plus 2 pi r square. Okay, So this is the surface area. Okay, but here right now if you see, this surface area involves RH. Okay, and both are variables. Okay, we don't know, and this expression involves both the variables. So what we have to do is either replace H, okay, or R. So make sure that this expression has is written only in terms of H or R, so that you can simply differentiate it and you can proceed on. Okay, so now how to from where we can replace this R and H. Okay, so this information will help you. Okay, because already it's saying that volume is fixed. Okay, volume is given to us. Okay, and how much volume is given to us? V is equal to 539 upon 2. Okay, but V is what? Pi r square H. So from this expression, either you find H values or R value and replace over here. Okay, so what I will do is I will take value of H in terms of R. So I will get H equal to 539 upon 2 pi R square. Okay, 2 pi R square. None. Now this total surface area 2 pi RH plus 2 pi R square. So what we will do is we will replace this H by this. Okay, so now if you see this total surface expression of this total surface area, okay, is in terms of R. Okay, so now we will differentiate this S, okay, with respect to R. So after differentiating, you will get this minus 539 upon R square plus 4 pi R. Okay, now for maximum or minimum, the first derivative should be equal to 0. So I have put equal to 0. Now solve it. So you will get some value of R. Okay, so here when we will solve, we get R equal to 3.5. Okay, now next step is to find the second derivative. So for second derivative, this is your first derivative, so differentiate this again with respect to R. So after differentiating that, you will get this. Yes, so you can see that you get 2 into 539 upon R cube plus 4 pi. So now what you have to do is, next step is you have to find this derivative for R equal to 3.5. So we find this derivative for R equal to 3.5. So wherever we have got R, we have to replace that by 3.5. So we put this value here. Numerator is positive, here R is positive, so cube is positive, pi is constant, okay, that is positive, 4 is positive, here plus sign is there, so automatically this will be greater than 0. Okay, so second derivative for R equal to 3.5 is coming greater than 0. Okay, so that means your S is minimum when R is equal to 3.5. Thus S is minimum for R equal to 3.5 units. Okay, so total surface area will be minimum when radius is 3.5. Okay, for that particular cylinder whose volume is 539 upon 2. So once you know the radius, you can find the height. Okay, from this H equal to 539 upon 2 pi R square. Okay, so here in R, right, 3.5, solve it, you get 7. Okay, so for that cylinder whose volume is 539, okay, we'll have minimum total surface area if you take radius to be 3.5 and height to be 7 units. Okay, so this is all for today's lecture.